Let's jump right into this explainer. Today, we're unpacking a massive release from NVIDIA, the Nemotron 3 Ultra. We're talking about a staggering 550 billion parameter model, and we're going to see exactly why this thing is an absolute game changer for autonomous AI. If you've been watching the shift from simple conversational bots to complex, multi-step agents, well, this is the engine designed to power that entire transition.
To really get why this model is such a big deal, we have to contrast a standard single-turn chatbot with a long-running agent. Think of a chatbot like a sprinter, right? It has a short memory, it does one task incredibly fast, and boom, it's done. But a long-running agent, that's a marathon runner. It needs a massive context window, it orchestrates multiple steps over hours, and it's actively researching, planning, and executing across hundreds of interactions. And that brings us to the elephant in the room, cost. As these AI tasks stretch out for hours and the tokens pile up into the hundreds of thousands, how in the world do you keep compute costs and memory usage from just spiraling totally out of control? I mean, if you use a massive, dense model for every single step of a marathon task, your budget is going to evaporate. So here's our roadmap for the next few minutes. 1. From chatbots to agents. 2. Unpacking the hybrid architecture. 3. Built for speed and scale. 4. Frontier performance and benchmarks. And 5. Deploying the Ultra model. From chatbots to agents and the shift to persistent AI. We are well and truly moving into an era where AI doesn't just answer a quick question for you. Instead, it's taking on complex, sustained tasks. We're talking about deep coding sessions across massive repositories, heavy research workflows that have to juggle hundreds of conflicting sources, and the automation of crazy, intricate enterprise workflows. Again, it's the shift from a quick sprint to a full-on marathon. And the demands placed on these marathon-running agents are just wild. They have to plan out complex tasks, seamlessly call external APIs, launch and delegate to subagents, and crucially, maintain a coherent history over hundreds of turns. Plus, they have to recover from errors without losing sight of the main goal. All of this takes immense reasoning and context capacity, which usually makes it way too slow and expensive to run on standard dense architectures. Moving right along to Section 2, unpacking the hybrid architecture, the 10% sparsity magic. The big headline number for Nemotron 3 Ultra is its total parameter count. It sits at a massive 550 billion parameters. That's what gives this model the deep knowledge and heavy reasoning capabilities of a giant frontier model. It literally knows a lot. But here's the kicker, and honestly, this is the magic trick. Out of those 550 billion parameters, it only activates 55 billion per token. That is just about 10% sparsity. By using this sparse mixture of experts' design, you get the absolute brainpower of a giant model, but with the energy bill of a much smaller one. Under the hood, we're looking at a hybrid Mamba-Transformer architecture. See, standard transformers scale quadratically, which just eats up memory on long texts. So instead, NVIDIA uses Mamba layers to handle those massive long sequences super efficiently. But they cleverly kept a few specialized attention layers from the transformer side, so the model can still find a specific tiny needle buried deep inside a massive haystack of context. And they definitely didn't stop there. They packed in innovations like latent MOE to quickly route tasks to the right expert inside the model. They added multi-token prediction so it can actually predict multiple words at once, dramatically boosting generation speed. Plus, it uses NVFP4 quantization to run highly optimized on GPU hardware. And the absolute best part, it's under the Open MDW 1.1 license, meaning enterprise data sovereignty is fully supported. Let's hit Section 3. Built for speed and scale, high throughput, lower cost. Because of that 10% sparsity and the hybrid engine we just talked about, Nemotron 3 Ultra hits up to 5 times faster inference throughput compared to similar open models in its class. If you're running high-volume agents, that speed isn't just a luxury. It's literally the difference between a workflow that works and a total bottleneck. And what does that mean for your budget? Well, for developers running multi-turn agentic workflows, that blazing fast speed translates to a massive 30% drop in operational costs. The longer the agent runs, the more money you save. Plus, it natively supports an absolutely massive 1 million token context window. To put that into perspective, in testing, it successfully pulled a single hidden passphrase out of 600,000 tokens of text in just about 35 seconds, with 0 hallucinations. That means it can hold entire codebases or huge research libraries in its head all at once, flawlessly keeping track of everything over sustained sessions.
Moving right along to Section 4, Frontier Performance and Benchmarks, going head-to-head. Nemotron 3 Ultra goes right up against massive frontier models like Kimi K2.6 and GLM 5.1. But look closely at where Ultra really shines. It hits 91% on PinchBench for agent productivity and 82% on IFBench for instruction following. It is completely optimized for the exact skills an agent needs to actually get its job done.
It also holds a serious edge in professional workloads. On SWEbench Verified, which is basically the gold standard for coding agents, it scores a highly impressive 71.9, alongside really strong numbers on Terminal Bench. So yeah, it's not just making small talk, it's putting in the work. Finally, let's hit Section 5, deploying the Ultra model and bringing a 550 billion parameter beast to your data center.
So, the biggest takeaway here is sovereign AI. Because the weights and recipes are open, you don't have to ship your sensitive enterprise data off to some closed API provider. Whether it's confidential manufacturing specs, healthcare records, or government data, you can run this top-tier model safely and securely locked down inside your own data center. And NVIDIA actually makes the deployment process pretty straightforward using their NIM microservices, which handles all the heavy lifting of containerizing and caching the model. You just generate an NGC personal API key, set up a local cache directory on your host, pull the NIM container image, and run it with your specific pass-through arguments. Simple as that. Now, we do need to talk hardware, because this thing is a heavyweight. You are going to need data center-grade multi-GPU servers. We're talking a minimum of 4 B200s or 8 H100 80GB GPUs, because it needs over 600 gigabytes of VRAM to run effectively. It's serious hardware for serious tasks. But hey, if you don't have a massive server rack sitting around, you can easily test it via APIs on build.nvidia.com or Amazon SageMaker Jumpstart right now. To sum it all up, this quote really hits the nail on the head. Ultra is not simply a bigger version. Its aim is placed on autonomous agents that run without stopping for hours. This isn't just another chatbot to ask for a recipe. It's a purpose-built, highly efficient orchestrator for the next generation of autonomous AI. The tools for sovereign, long-running, agentic AI are literally right here, completely open to you. The barrier to entry for running a frontier-level model entirely on your own infrastructure is gone. So the only question left for you is, what incredible marathon tasks will you have it run? Thanks for hanging out with me for this explainer, and I'll catch you on the next one.